Okay, so this is going to be for the worksheet, name that movie with quadratic functions. So number one, using the table, find the range of the functions. So whenever we're wanting to find the range, we want to concentrate on our y values, but one thing that we need to pull from the table is our vertex. So this is my vertex here. Okay, and the y out of this vertex is -2. And then what I'm going to look at next is to see if my numbers in the table are increasing or decreasing, and I can see that they are increasing. So that means my graph would be facing up. So that means y can be -2 or anything greater than -2. So we would say y is greater than or equal to -2. Okay, so let's take a look at our other table that we have over here. So this time our vertex is going to be 1, -4. And when I look at the table here, I can see that the numbers are increasing. So again, the parabola is going to be facing up. So that means y can be equal to -4 or anything greater than -4. So it would be y is greater than or equal to -4. Okay, number 2. It says the following data represents approximate heights for a ball thrown by a shot putter as it travels a distance of x meters horizontally. Find the equation that best represents the given data. Okay, so we have to use our calculator on this. So we're going to go to, and I'm going to get me a different calculator. Okay. So we have to go to Stat, Edit, and we are going to enter the distance into L1 and our height into L2. Okay, so now that we have our data entered into the calculator, we're going to go back to Stat, and this time we'll move over to Calc, and we want to go down to 5 because we're looking for a quadratic equation. So we're going to wait for it to calculate it, and there is our equation right there, but we're going to put it in the form of ax squared plus bx plus c. So I can see that my a is going to be negative, and we'll just round it to 0.01. My b is going to be rounded to 1.06, and c is going to be rounded to 0.24. So therefore, my equation would be negative 0.01 x squared plus 1.06 x plus 0.24. Okay. All right, so for number 3, the concentration in milligrams per liter of a medication in a patient's blood as time passes is given in the following table. So again, they're wanting us to find the equation that best represents the given data. So let's go back to, Stat, and then Edit, but actually let's clear our calculator so we don't have to worry about deleting all those other all the data from the previous question. So now we'll go back to Stat, Edit. So in L1 we will put the time, and then in L2 we're going to put the concentration. 0. Okay, so now that we have all of our data entered, we'll go back to Stat, move over to Calc, and hit 5 for the quadratic equation. And then let's write down our A, B, and C values. So our A is going to be equal to, we'll round it to negative, let's just do negative 56. Our B will round to just 139, and C we'll just make it 9. So therefore my equation would be negative 56 x squared plus 139x plus 9. Okay, now Now let's go to number 4. So number 4 says, which equation below has a vertex of -5, -2? So remember, we are going to think about the vertex form, which is x minus h squared plus k, where the x value is my h and the y value is my k. So that means my equation should be x, instead of saying minus, since my h value is negative, it'll become plus, so h plus 5 squared, and then minus 2, so c. Okay, number 5, which equation below has the vertex of -3, 4, and a vertical stretch of 2? So this time we have to include the a in our vertex form, so a times x minus h squared plus k. And again, the -3 will be my h, and the 4 will be my k, and 2 will be my a. So my equation would look like 2 times x, and again, since my h value is negative, my equation becomes, changes to a plus sign, so x plus 3 squared, and then plus 4. So it would be B. Okay, number 6. Which of the following equations would be best represented by this graph? All right, so when I look at it, I can tell that from here it has moved over. It's shifted to the right by 3. So if we remember correctly, whenever we have a minus h, that means we're going to go to the right. And when we have a plus h, we move to the left. So, and I believe we made a mistake on this paper. I need to put a negative sign here. So we would be looking at this negative times the x minus 3 all squared. So it would be C. Okay. Number 7, we need to graph our function. So this minus 2 right here, this is like my k value since it's outside of the parentheses. So that means that everything's going to shift down 2. So all I need to do is just count each point on here to 2 spots below it. And that would be my new graph. Okay. All right, so for number 8, we're going to do the same thing. We're going to graph the function. So again, this 1 would be my h, and we are going to be going to the right with it. And then my 3 is my k, so we're going to be going down 3. So starting right here, I'm going to go over 1 and then down 3. I'm sorry. Yeah, that's right. I'm going to go to the right 1 and then down 3. I'm sorry. And then starting at this point, I'm going to go right 1 and then down 3. And here, right 1 and then down 3. So I can see that my new graph would look like this. Okay. All right, so now flipping over to the back side. Okay, so write the equation of a parabola that is, let's see, number 9, shifted down 3. So again, that would be my k. And right 5, so that is my h from the equation, or from the quadratic parent function. And since I'm going to the right, that means I need a minus h. So my equation would be, starting with the parentheses, x minus 5 squared, and then since I'm going down 3, I'm going to say minus 3. Okay? Number 10, shifted up 2 and narrower than y equals x squared minus 5. Okay, if I'm going to be narrower, that means that a has to be greater than 1. And see, my a value is already 1 here, so let's just go ahead and make it 2. So we'll say 2x squared. And if I'm at -5 and I want to shift up 2, I have to say -5 plus 2, which gives me a -3, so it's just going to be 2x squared minus 3. Okay. Number 11, vertically compressed by 2 over 3 and has a vertex of 6, -1. So this 2 over 3 is going to be my a value, 6 will be h, and -1 will be k. So I would have 2 over 3 times x minus 6 squared minus 1. Okay, number 12. Which of the following functions is represented by this graph? Okay, so if we were starting at with our parent function here, if we were going to compare, we can see that we shifted over 1, 2, 3, 4, 5, and then we went down 2. So we would have a minus 5 and then a minus 2. This would be my H, this would be my K. So it would be C. Okay, number 13. Which statements below would be the correct description of the function g of x equals 3 times x plus 1 squared minus 4 compared to the parent function of f of x equals x squared? So we know that this is getting narrower because remember, if a is greater than 1, that means my parabola is getting narrower. And then since I have a plus h, that means I would be shifting to the left, and then a minus 4 means that's my k, which means I'm going to shift down 4. So a says g of x is wider than f of x, so already we can go ahead and cancel this one out because we know we're not getting wider. The same thing with b because it's saying g of x is wider. C says g of x is narrower than f of x and is shifted right 1, but we need to shift left 1. So let's check out D. G of x is narrower than f of x and is shifted left and down 4. So that's what we're looking for. Okay, so now moving on to number 14. Each equation of parent function y equals x squared. So I guess that's what we have right here. And wants to know which of the following would fit the data better. So we can see that it's shifted to the left, so that means we would have a plus h. And then we shifted down, so that'd be a minus k. So it would have to be C because that one is a plus 5, so that's my plus h, and then a minus 3, which would be my minus k. Okay, number 15. It says if a value of a parabola is 2 over 5, which statement would be true? So anytime 0 is less than a, which is less than 1, that means that my graph is becoming wider, or we could say compressed. So let's see. A says the parabola is vertically stretched by 2 over 5. So it's not going to be that one. B says the parabola is vertically compressed by 2 over 5, and that would be what we're looking for. Okay, so 18 through 20. There's it's not 18 through 20. Oh, to use the graph for 18 through 20, I'm sorry. So it says a ball is kicked into the air. The situation is modeled with the equation y equals 0.49 x squared plus 44.3 x. So number 16 wants to know how long the ball was in the air for. So since the x values are what is telling us the time, we can see it was from 0 to 9 seconds. 17 says the maximum height of the ball was approximately blank feet. So our maximum would be our vertex here. And we can see, and again, we want to look at our y value since it's talking about the height. So it would be at 100 feet was our approximate maximum height. Okay, number 18, the ball was at a height of 70 feet at blank seconds and blank seconds after it was thrown. So again, since y is representing the height, we could say that y equals 70. So what I'm going to do is come over here to my y-axis, and I'm going to draw my horizontal line to represent y equals 70. And I see that it intersects my graph here at this point, which would be 2, and then also here at this point, which would be 7. So the ball was at a height of 70 feet at 2 seconds and 7 seconds. Okay, and number 19 is wanting to know the range of the situation. So let's see. We've already discovered that from our vertex, our maximum height, with the maximum height, our y value would be 100 here. So we know that y can equal anything at 100 or anything below it all the way to 0. So our range would be 0 is less than or equal to y, which is less than or equal to 100. Okay, and this concludes this paper. And you can turn it into me tomorrow. Thanks.